Hey, welcome folks to this next presentation. This is going to be of my good friend Ted Konyi. He is the CEO of a company called AirTest. And, you know, we've talked a lot at this conference in the terms of green energy, energy savings, about lithium and cobalt and things like that. But there's a lot of really cool companies out there, AirTest being one of them that I've already recommended the national investor, that aren't in mineral extraction and that type of thing, but they basically have got cutting edge technology to show businesses and people how to reduce their usage of electricity and thereby reduce mankind's carbon footprint on the planet. So this is a great story. It's a company that is really under a lot of people's radars. But I think that's going to start to change. He's brought some good talent on in the recent past. And I'll let you hear all about that from him. So Ted, glad you could join us for this conference and take it away.
Hey, Chris, thanks for that. And welcome, everybody. Appreciate you taking the time to watch. Chris, you've always got such nice words, and we've gotten to know each other fairly well and agreed that there's lots of ways for the world to reduce their carbon footprint. Certainly, you know, the things that you're focusing on in terms of lithium and cobalt and so on are all important for the electrification of cars and everything else. But there's also energy efficiency. It's use less to do the same or more. And that's another way of reducing carbon footprint. And that's really where AirTest is quite focused. The business has been around for 20 years. We've been in the sensor business, but there's been some recent events that I think are really going to change the nature of this company, its revenue profile, its profitability, et cetera. So I'm very excited about being a part of it and happy to talk about it. So the key point is measurement of whatever it is that you're going to try and control or manage. You cannot manage what you don't measure. And basically sensors and the whole IoT field is all about measurement. And so that once you understand what's going on, then you can actually do something about it. There's a paradigm shift that's underway. It's a matter of looking at reducing energy consumption in buildings. That's what we're focused on. It will obviously positively impact the carbon footprint, the global environment, by reducing the amount of energy that's consumed in buildings. Well, how do you do that? You know, where do we fit in, I guess, is the key. Wireless technologies really do provide an opportunity to change the business model, hence the paradigm shift. Typically, buildings have looked at energy efficiency from strictly a financial model perspective. And the golden rule seemed to be a 2-year payback. In other words, if you could provide an energy efficiency technology, whether it was LED lighting or changes to HVAC systems, the deployment of variable frequency drives, and all kinds of other technologies, if you could get it done down under 2-year payback period, now you had something to talk about. And AirTest has been in that zone for quite a while, but it's about to drop the cost and thereby increase the financial benefit to the customer, making it almost a no-brainer. And that's what I really want to talk about today. So specifically, the problem in a lot of buildings is that under building code, and I'm really referring specifically to commercial buildings and buildings that the public goes into. So I'm referring to things like stores and schools and government buildings and offices and theaters, anywhere where the public goes in. There's a requirement under the building code that those buildings have to be ventilated with fresh air. That's common sense. We all breathe in oxygen and we breathe out CO2. And so if there's no fresh air being brought into an enclosed space, obviously the CO2 levels are going to climb and climb and climb, where we'll all fall asleep. So building code specified that you have to have fresh air come into a building. And the reality is that the fresh air that is required under building code to be brought into the building is based on the maximum occupancy of that building. So not to pick any specific examples, but if you took a commercial grocery store that might be a 50,000 square foot store, that commercial 50,000 square foot grocery store might have a capacity of 500 or 600 people in it at any one time. Because of that, 500 or 600 people, they've got to ventilate. They've got to bring in fresh air for those 500 or 600 people. However, as the accompanying slide will show, the number of times or the amount of time that that store has that kind of population in it is almost nil. And when you think about it, when you go into a store, how often, say on a Monday morning at 10 o'clock, do you see, 500 people in a grocery store? You don't. You might see 5 or 10 people in a grocery store, but unless the store is measuring the CO2 levels and is controlling the amount of outside air that's being brought into the building based on CO2 levels, because CO2 levels are basically a proxy for the population, more people, more CO2. Unless they're measuring it, they have to ventilate that space for the maximum occupancy. They have to ventilate that space, assuming that there's 500 people in the store. And if there's not, then what's happening is that every time they're bringing in fresh air, the amount of fresh air that they're bringing in, this is not a balloon that's going to expand in size. They're exhausting conditioned air, air that they've already either heated if it's in the middle of wintertime or cooled if it's in the middle of summertime. That's being pushed back out the door or out the air handling system. So, okay, if you're bringing in outside air in the middle of wintertime and it's 10 degrees outside and you're having to heat at 72 degrees, that's a lot of energy that's being burned, and most of that energy is natural gas in North America because natural gas has been cheap. And I'm going to come back to that comment in a minute. It's something, of course, this covers fairly regularly in terms of energy costs. So, and then in the summertime, of course, it's the opposite. You're air conditioning all the outside air. If it's 85 degrees outside and you want it to be 74 degrees inside the store, you're bringing that temperature from 85 down to 74, and you're exhausting all of the already conditioned air. So you're wasting a ton of energy. The estimate is that heating, ventilation, and air conditioning represents about 35% of the building's energy expense on average. And that's a big chunk of what can be saved by, in fact, deploying a protocol known as demand control ventilation. Demand control ventilation, as you might expect from what the words are, DCV, is all about controlling the amount of outdoor air based on demand. And that demand is being dictated by the CO2 levels. So the fact that if you have CO2 sensors, you can then have those CO2 sensors provide the data to the outdoor air dampers. These are vanes that open and close. And if the level is below the prescribed requirement under the ASHRAE guidelines, the building code guidelines, if it's under 1,000 parts per million, keeping in mind that CO2 is what everybody's worried about as far as the environment is concerned. Ambient CO2 is now at about 420 parts per million. We can all live comfortably at 2,000 parts per million, but they've set 1,000 parts per million as the level that if it's below 1,000 parts per million in the store, you can actually close the outside air dampers and therefore recirculate the air and condition already conditioned air, which is going to save a tremendous amount of energy, both in heating in the wintertime and in cooling in the summertime. So using CO2 sensors, and this protocol of demand control ventilation, or DCV, has been around for a long time. ASHRAE adopted it about 20 years ago. So the question is, well, where's the opportunity? Why hasn't everybody done this? This makes perfectly good sense. And I can tell you that the penetration in these kind of retail stores, theaters, offices, etc., of demand control ventilation is maybe 20%. 80% of locations have, or buildings have not deployed demand control ventilation. Why? Well, most of the sensors that were on the market and still are on the market are sensors that require wiring to provide the data from inside the store where the sensor is located to the rooftop air conditioning unit to then open and close that outside air. And that wiring in a retrofit situation requires a tremendous amount of labor. And because it's a commercial building, it requires conduit and wires, of course. So the cost has been somewhat prohibitive. Typically $2,500 per sensor point in a 50,000 square foot store, you might need 10 sensor points. So you might need $25,000 to outfit the store. Plus, if you're doing a retrofit, it's invasive. You've got to have people in there running conduit from these sensors to the rooftop unit. So we've developed what you see above me here, the IQI, which is revolutionary. It's not the only one on the market, but it's one of the very few on the market at the moment that is in fact a completely wireless CO2 sensor. Not wireless in the form of power. It can be either powered with a 24-volt AC from a thermostat, or it can be powered by battery. But the wireless is reflecting on the data that's being communicated to the rooftop. So when that data gets communicated to the rooftop can then open and close. But in the meantime, the cost associated with this drops from $2,500 to somewhere between $1,000 and $1,200 per sensor point. So you've dropped the cost in half, which conversely means that the return on investment for the customer is twice what it was. It means the payback period is half of what it was. And then further than that, if you include the typical energy efficiency subsidies that are available, and believe me, they're growing. In fact, I'm from Canada and Ontario now. This protocol of demand control ventilation has two sets of subsidies, one from the natural gas provider. In the case of Ontario, it's Enbridge, which is $550 per sensor, or basically 50% of the cost of installation of the new sensors. And in addition to that, the Ontario government energy efficiency subsidy program called Save on Energy provides 50% of the balance. So in Ontario, 70% of the cost of deploying demand control ventilation is covered by subsidy. It's an amazing scenario. It truly is in that no-brainer category. So, you know, we're having quite good success in Ontario with talking to very, very large retail chains about deploying demand control ventilation. So what are the drivers for this? As I've said, the primary driver is financial savings. That's been the primary economic model. Clearly, from what I've said, the IAQI cuts that by probably 2/3 in most cases. Energy costs have risen quite dramatically recently and are about to rise even more dramatically, and I'm going to come back to that in a minute. More and more, there are rebates, government subsidies, utility subsidies for demand control ventilation. And lastly, because of the concern about the global climate situation, all kinds of companies now have ESG mandates and sustainability managers, and they're looking to reduce their carbon footprint. And this is a very easy solution for them to assist in doing that. So back to energy costs. You know, I attended recently a conference specifically for multi-site retailers in Long Beach, California. And I got the chance to talk to people, you know, like the Gap and Bed Bath & Beyond and Sephora and a number of others. And when I was in discussion with them, we were talking about energy costs, and I said to them, I said, are you aware of what's coming down the road here? And what I'm referring to specifically is most of these stores are being heated in the wintertime if they're in the northern climates with natural gas. The input cost of natural gas, which is traditionally in the last, say, 5 years, hovered around $2 to $2.50 per 1,000 cubic foot, is now hovering around $7. That cost is going to be passed on to the consumer. There's no way that a gas provider is going to pay $7 versus paying $2.50 to the producer and not pass that along. So this is going to create a huge increase, maybe not immediately, but down the road. Now, that's assuming it's sustained. I have a reason to believe that it will be. In addition to that, and probably as importantly, electricity, which is primarily used for air conditioning, is going to go up significantly, has gone up, and is going to go up even more significantly. And the reason for that is the same. In North America, electricity is generated still 60%, 61% almost, with natural gas and coal. And where we've already talked about natural gas going up almost 300%, coal has gone up almost 600%. Coal traditionally is sold for $50 a ton. It's now $320 a ton. And so that input cost, ultimately the utilities, sure, they're on long-term supply contracts, but when those contracts come to an end, which will be over a period of time, they're going to be forced to pay that now new price. And there's no way that they're not going to pass that along to the consumer. So again, this is going to create far more motivation for all of these people that are in this position of looking at their buildings and looking to cut their operating costs, looking to cut their carbon footprint, to look at things like air tests. So I then have a picture here, so the picture's worth 1,000 words on this slide about rooftop units. So most of the air conditioning and heating in America for commercial buildings, retail stores, malls, grocery stores, etc., is done with these rooftop units. They're called packaged units. In the picture, you'll see there's a yellow pipe. That's the gas pipeline that's being fed in for heating in the wintertime. And then the electricity is used to run the compressor for the refrigeration portion of the system. In any case, these costs are going up. The other picture I've got here is a picture of a typical mall, and I've circled in green all of the rooftop units on this mall. There's 20 million rooftop units in North America. And 80% of them are ready for CO2 input. They're plug and play. So again, in terms of a driver, with the advent of a wireless CO2 sensor that can communicate wirelessly to the rooftop unit, where we have a receiver unit, it's such a simple installation I can do. It's literally putting these sensors on the walls or on pillars inside the controlled space inside the store or the theater or wherever you're wanting to control it and measure it. And then the receiver unit goes on the rooftop where there's already two little screws that allow you to input the analog signal to control those dampers and open and close the ventilation. So it's really an inexpensive, simple process to install this. And that's another one of the key points here. Got a picture of our new IAQI, which does carbon dioxide, of course, temperature, relative humidity. It has a lot of feature sets. And we've got a variety of different approaches, as I said, powered or through battery. I've also got on the next slide, the AirTest, a sample proposal. This is an actual mall that we've done a proposal for. It's 800,000 square feet. It has 43 of these big rooftop units on it. The anticipated savings for both electricity and natural gas for this particular example is $180,000 a year. The installed solution from AirTest that we proposed is $260,000. I've got in the slide a 50% government efficiency subsidy, but in fact, this mall happens to be in Ontario, and it's going to be more like 70% subsidy. So the net cost to the customer is going to be about $100,000, which means that the payback period is going to be somewhere in the neighborhood of 6 to 7 months. It's really very much a no-brainer. I've got a couple of case studies. One for Lowe's, which we worked with an intermediary and installed 600 Lowe's stores with AirTest sensors. Now, this goes back a ways, but it was when it was wired. And the reason Lowe's only did 600 out of 1,700 stores was that the subsidy program only made sense where the electricity costs and the natural gas costs were higher. So with our new IAQI, we've reapproached Lowe's to talk about the other 1,100 locations that they've got. We've done a number of IKEA stores as well, another example that we've got here. So, okay, how big is this market? Well, in 2012, and I haven't seen more recent data, unfortunately, but in 2012, the U.S. Energy Information Group came up with the number of $92 billion in annual HVAC costs. Now, I can assure you it's going to be quite a bit higher today than it was then. But $92 billion in annual HVAC costs for commercial buildings. We anticipate a 30% energy efficiency gain. We think that means there's about a $55 billion market for wireless sensors. Our initial target market are grocery stores. There's about 160,000 of them. We've estimated 25,000 a store. That might be a little on the light side, but still, that's 3.2 billion of market. And then North American retail store chains. That's about another $3.75 billion market opportunity. Chris alluded to some changes that have been made recently. In addition to my coming on as a CEO last year, I've added a fellow by the name of Robin Schaefer as the Director of Sales and Marketing. Robin has an extensive background in working with very large controls companies like Johnson Controls, where he led their sales team for a 10-year period of time. Mike Schell, our Chief Technical Officer, actually wrote the original white paper for ASHRAE relative to this protocol of demand control ventilation. So he's very much an expert in the whole ventilation piece. Then we've got our financial data. So that's really the story. The story here is that there's a massive opportunity. It's a perfect storm from my perspective. Energy prices are going through the roof and are going to continue to go through the roof for some time. You've got now a whole lot of new mandates relative to reducing carbon footprint. And we've got a wireless sensor that reduces the cost and the invasive nature of the installation, so that it's the perfect storm. We're in a fabulous position at the moment.
Ted, that's great stuff. And of course, I already mentioned earlier that this is one of my recommendations on energy saving international investor for our members that I made a little while back. You know, in looking at this, I don't know how anybody could disagree that this technology and the potential uptake by way more customers really is a no-brainer. I guess in just a couple minutes we have left, Ted, if you could give us a narrative of what right now stands in the way of AirTest capitalizing on this in a much bigger way. What are the kind of pieces that you've put in place and still need to put in place in the near term?
So, you know, everybody says, well, when's this all going to happen? When's this going to happen? And, you know, having done a fair amount of fishing, I use a fishing analogy. We've got a number of whales on the line. It's a process. It's not, you don't walk into, and I won't pick any particular name, but you don't walk into a major retailer and then literally walk out, you know, half an hour later with an order in your hand. We've got lots of whales on the line. We're working with 6-pound test. We can't horse them in. Some are extremely close is all I can really share at this point in time. So I think the thing that's going to make the change is, you know, it's a process. We're well underway with a number of very, very large retail chains. In fact, I've said to the team, literally, we would have a major problem if more than 2 or 3 agree to go forward. We've done lots of pilots with these people. They're already aware of what the program is. They've become much more motivated, as I said, because of the current environment. I expect that we will see very shortly 1 or 2 of these major chains come on. And we're not talking small numbers. We're talking, you know, one in particular, the proposal is over $12 million. You know, for a company that's hovered around the 3 million per year, 3 to 3.5 million per year range, that's a game changer. And to me, it's a game changer from another perspective too. I do believe we're going to land a couple of these big clients, and when we do, you know, nobody wants to be first. You got this new fancy, you know, wireless technology. That's great. It sounds fabulous, but nobody wants to be first. But trust me, there will be a rush to be second, and then it's going to be a logistical issue for us. Which, please give me that problem. That's what I'm looking forward to.
No kidding. That would be a nice problem to have. And I'm glad you stressed the point that this was a great story before gas was $7 plus and before coal had gone up. And now the gun is to the head of a lot more potential customers that could have dragged their feet and can't anymore. Hey, Ted, our folks here appreciate it. I appreciate it. Our whole crew, if there's any follow-up questions, of course, we'll be gathering them for you. If I can answer any half intelligently, I will. Otherwise, we'll pass them along to you. So thanks, Ted, very, very much for telling us the AirTest story.
Wonderful. And listen, Chris, I appreciate it. And I'm hoping next session that you've got, I'm there in person, because I'd love to be glad handing a lot of people about this opportunity.